Beneath the rolling blue of the world's oceans lies a realm of crushing pressure, perpetual darkness, and mysteries that have eluded humanity for centuries. In the Mariana Trench, the deepest known point on Earth, water reaches a depth of nearly 11 miles, a pressure equivalent to 1,000 jumbo jets stacked atop one another. This is the frontier where science meets the unknown, and where the most astonishing discoveries have been made, creatures that defy biology, minerals that rewrite geology, and clues to Earth's earliest history. The first glimpse into these abyssal depths came not from a submarine, but from a simple echo. In the 1950s, the U.S. Navy's bathyscaphe Trias descended into the Challenger Deep, recording the faintest whispers of sonar that mapped the seafloor for the first time. Those early sound waves revealed a landscape of sheer walls, flat abyssal plains, and scattered volcanic peaks, features that would later become the stage for life forms never before imagined. Among the most iconic inhabitants of the deep is the giant amphipod, a crustacean that can grow up to 30 centimeters, larger than its shallow water relatives. Adapted to survive at pressures exceeding 1,100 atmospheres, its exoskeleton is reinforced with a unique protein matrix, allowing it to retain flexibility while resisting collapse. These amphipods are not merely larger, they possess enzymes that function optimally where most proteins would denature, offering a living laboratory for biochemists. Equally astonishing are the tube worms of the hydrothermal vent fields that pepper the trench walls. Lacking digestive systems, they host symbiotic bacteria that convert sulfur-rich vent fluids into organic carbon. Their red plumes, pulsating with blood rich in the copper-based pigment hemocyanin, give them a vivid, alien appearance. These ecosystems thrive in total darkness, powered not by sunlight but by the Earth's internal heat, a reminder that life can flourish under the most extreme conditions. The deep sea is also a repository of ancient geological records. Sediment cores extracted from the trench floor contain microfossils dating back over 70 million years, preserving a continuous archive of climate change, volcanic eruptions, and even asteroid impacts. By analyzing isotopic ratios within these layers, scientists reconstruct past ocean temperatures and atmospheric composition, providing a window into Earth's prehistoric climate and informing predictions for the future. Beyond biology and geology, the trench harbors a trove of rare minerals. Manganese nodules, massive concretions of iron, copper, and rare earth elements, dot the seafloor like ancient pearls. Their slow formation, growing a millimeter every million years, makes them a potential source of critical metals for renewable technologies, yet mining them poses unprecedented engineering challenges and ethical dilemmas about disturbing a fragile ecosystem. Perhaps the most enigmatic residents are the bioluminescent organisms that paint the darkness with fleeting glows. The dragonfish, with its transparent skull and fawn-like teeth, emits a cold blue light to lure prey. Its photophores are controlled by a sophisticated neural network, allowing precise patterns that can confuse predators or attract mates. These light shows are not just spectacle, they are communication tools honed by evolution to survive where sunlight never reaches. In recent years, autonomous underwater vehicles have expanded our reach. The Japanese ROV Keiko and the American submersible Nereus have logged thousands of hours exploring trench walls, capturing high-definition footage of previously unseen species such as the snailfish, which can survive at pressures over 1,200 atmospheres. These machines carry instruments that measure temperature, chemistry, and acoustic signatures, turning the abyss into a data-rich laboratory. One of the most surprising discoveries came in 2014, when a team retrieved a piece of plastic debris from the Challenger Deep. The find underscored a sobering truth: humanity's impact reaches even the most remote corners of the planet. Microplastics have been found embedded in the gut tracts of deep-sea amphipods, suggesting that the food web is already being altered by pollutants that travel thousands of miles on ocean currents. The trench also holds clues to the origin of life itself. Hydrothermal vents provide the chemical gradients necessary for prebiotic synthesis, and the mineral-rich chimneys act as natural catalysts. Experiments replicating these conditions have produced simple organic molecules, hinting that life may have begun in environments similar to today's deep-sea vents, far from the sun's warmth. Beyond Earth, the study of these extreme habitats informs the search for extraterrestrial life. Moons such as Europa and Enceladus possess subsurface oceans beneath icy crusts, where hydrothermal activity may exist. By understanding how organisms thrive in Earth's abyss, scientists refine the criteria for life on other worlds, turning the deep sea into a proxy laboratory for astrobiology. Yet, despite technological advances, more than 80% of the ocean floor remains unmapped in high resolution. The International Seabed Authority estimates that each day, an area the size of New York City is explored for the first time. This vast unknown harbors potential new species, untapped resources, and geological processes that could reshape our understanding of plate tectonics. International collaboration is now the cornerstone of deep-sea exploration. Projects like the Global Ocean Floor Initiative bring together governments, universities, and private firms to share data, develop open-source mapping tools, and train the next generation of oceanographers. The collective effort aims not only to chart the abyss but also to protect it, establishing marine protected areas that safeguard vulnerable ecosystems from overexploitation. The story of the deepest parts of the ocean is still being written. Each descent uncovers new forms of adaptation, each sample reveals a fragment of Earth's ancient past, and each discovery reshapes our perception of life's resilience. As we stand on the brink of a new era of oceanic knowledge, the abyss beckons, inviting us to look deeper, think broader, and cherish the hidden world that lies beneath the waves. Beneath the crushing pressure of the Challenger Deep, a lone organism clings to a volcanic vent, thriving on chemicals that would poison any surface-dwelling creature. This chemosynthetic marvel, a tube worm of unprecedented length, demonstrates that life can flourish where sunlight never reaches, rewriting the limits of biology and hinting at ecosystems that could exist on icy moons far beyond our solar system. The abyssal plains, once thought to be barren sandscapes, are now known to host vast gardens of sponge forests. These living structures filter millions of liters of water each day, creating microhabitats for shrimp, crabs, and fish, and playing a crucial role in carbon sequestration that helps regulate the planet's climate. Recent expeditions have uncovered ancient DNA locked within the sediments of the Mariana Trench, revealing species that vanished from the surface eons ago. By comparing these genetic time capsules with modern relatives, scientists can trace evolutionary pathways and better understand how climate shifts have reshaped marine biodiversity. Hydrothermal plumes rising from the trench's fissures act as highways for microscopic plankton, transporting nutrients across ocean basins. The extreme acoustics of the trench reveal a hidden soundscape, low-frequency rumblings from shifting tectonic plates, the clicks of giant squid, and the subtle hum of bioluminescent organisms communicating in darkness. These sounds are being catalogued to monitor seismic activity and to study the behavioral ecology of the abyss. Beyond scientific curiosity, the abyss holds untapped resources, rare earth elements and methane hydrates, sparking debates over sustainable extraction. International treaties now grapple with balancing economic interests against the preservation of these fragile ecosystems, a modern echo of past exploitation on land. Finally, the human story intertwines with the trench's mysteries. Indigenous legends of sea monsters and bottomless pits have long spoken of these depths, and today, a new generation of oceanographers carries that awe forward, using autonomous submarines to push the boundaries of what we can see, hear, and understand beneath the waves.